Yeah, it's good. Yeah, sorry guys, another PC crash. I hope it's not going to be like that for this whole evening. Really frustrating. Sometimes it'll be fine for hours and hours and hours. It's a hardware crash, it's not software related. Hello for the third time. So yeah, all emitters out and all transistors out. So let's turn our attention to the internet and see if we can find these parts somewhere. uk.rs, uk.farnell, uk.farnell.com, and Mercadillo. I finally fixed the problem with the voltage spikes on the drains of FETs on the base clone amp. Trying to remember what the issue was. Yes, how did you fix it? What was the problem? Be interested to find out. So, we need two, what was it? I lost my notepad thing. 2SA, what's this say? 1302. 2SA 1302. Do you have them? Nope. Won't have them either. Probably won't have them either. No. Okay, so we're looking for alternatives. Okay. 2SA 1302. What's this? What is this? So the PC crashing, guys, is not a software issue. It is a hardware halt. It is a hardware level halt on the motherboard. And the reason I know this is because in Windows Event Viewer, there is absolutely nothing. It's almost as if you just pull the plug out of the wall. There's nothing. Like, the computer's on, and then the next update on Event Viewer is just system started at time. So there is nothing in Event Viewer, nothing in blue screen view. It's a hardware halt. So that says to me, motherboard is unhappy. Maybe the USB 5 volt drops below a threshold. Maybe the power supply like glitches or something, or like, you know, the 5 volt disappears and then comes back for a split second, causing this lockup. But yeah, it's hardware related, so it needs some upgrades. The software is fine. Damning with the 199, man. Thank you very much, my friend. Work laptop. Yeah, that's what I need. Not, but yes, I need something like that. It was caused by high duty cycles, and even though the FETs are genuine and from the same batch, they were cross-conducting at 50% duty. Yes, they will cross-conduct at 50% duty. You shouldn't have 50% duty on the power supply. I assume you're talking about the power supply. The power supply should be driven with at most like 49.5% duty. Usually you see anywhere between 42 and 48% duty cycle on the power supply. Yeah, you shouldn't be seeing 50% duty from side A and side B on the power supply, because yeah, you're going to get ridiculous cross conduction. And if that is 50% duty cycle coming from the MCU, then that is a programming fault. That is a design flaw in the code for the MCU. It shouldn't be that high. You can mitigate that by installing some pretty high value gate resistors like 100 ohm gates, and then a 4148 diode in parallel across the gate to pull the FET off quickly. So it turns on slowly, so you get a little bit of time. You get a little bit of extra time before the FET turns on to assist. The CPU in my PC is a 4690K, pretty old, pretty slow. Does what I need though, because all of the rendering and for the live streams are done by the GPU, which is a 780 Ti. Again, very old, but again, I'm not gaming. This is just for encoding video. The performance of the PC is actually fine. It's just hardware. It's the motherboard that's the problem. Oh, you fixed it by changing the dead time. So was the amplifier? No, the amplifier wasn't using a 494. How did you change the dead time? Because those amps use an MCU, don't they? So what did you do to change the dead time? Anyway, so yes, the transistors used in this amp. The PNP side, it is 200 volt rated. Okay, well that makes sense, I think, because yeah, we've got 160 volt rails. So yeah, that makes sense. So we've got 200 volts. We've got the collector current is 15 amps. We've got 150 watt dissipation. That doesn't seem like very much, given the size of these beasts. But I guess I'm comparing that to modern MOSFET tech, so fair enough. Yeah, complementary to the 2SC 3281. Okay, HFE. As we have already seen, we are looking for somewhere between 55 and 160. All right, fantastic. So we have a baseline to go by. The package that these are in, we don't actually have to necessarily stick to. For replacement transistors for this, we can either use these larger package transistors, or we can actually go for 247AC or TO3PN, because they will all fit just fine in these locations, which is really, really nice. So we should have plenty of options for compatible replacements. So let's turn our attention to RS components first of all, I think, and let's have a little butchers and see what we got on RS, and then we'll do the same for Farnell, although I absolutely hate Farnell's filtering system. It sucks. So let's go for semiconductors. Let's go for discrete semiconductors. RTS says no, they're actually using a TL494 alone on the clones. Interesting. And I changed it by applying 1 volt to the pin 4 of the TL494. That's very unusual. The TL494 can't actually do 50% duty cycle from what I remember of the datasheet. It can do a percentage, it can do like 49.8 or something like that. But yeah, cool. That's really good that you sorted that. And if you're getting a 49% duty cycle, then that's more than enough. Speaking of switching FETs, anyone know why do IRF 640N die on a plus minus 45 volt PSU single end output with a switching frequency of 344 kHz? It has snubbers per drain source, 33 ohm gates with 4 1/4. Can't really answer that without without seeing what the flaws are on the circuit. So when are they dying? Are they dying when the amplifier powers up? Are they dying when the amplifier is just idling, doing nothing? Are they dying when the amplifier is under heavy load? Yeah, what is the scenario that's causing them to fail? But there doesn't look like there's anything inherently wrong here. 33s with 4 1/4, probably fine. Check the gate drive wave, see what it looks like. Obviously the voltage is fine. Those are 200 volt parts, and you've got 90 volts worth of rail potential, so that's fine as well. 344 kilohertz is like not stupidly high, like well within the limits of the 640Ns. Are they genuine? Where are they being bought from? Are they genuine 640Ns? Under load, and the scope catches weird spikes. Most ringing is gone because of the snubbers. So yeah, if they're dying under load, then either the load is too much for the circuit. Are the 640Ns clamped to the heatsink while you're testing this? Just I'm sure they are, but you have to ask. So it's not that they're overheating, hopefully. It could be that under load, some of the auxiliary supply voltages are like sagging too low. If they originate from the main rails, so check that. Ideally, in this scenario where you're doing R&D or like this kind of troubleshooting, it would be really useful to have a data logging oscilloscope, so that you can have like 4 probes plugged in, monitoring all the auxiliary supply rails, or the output switch wave, the drive wave, etc., and then drive the amplifier to fail, and then look at the data log from the oscilloscope to see what went wrong. That would be pretty useful. Anyway, back to our transistor rubies. We need some, I think it's bipolar transistors, right? Yeah, it's got to be. And then we are looking for a collector emitter voltage of, oh yes, PNPs and NPNs. We'll start by looking for PNPs. I've got a feeling there will be less PNPs available than NPNs. So if we find a compatible PNP, then we can just find its complementary. So let's go for, oh, there's only 8? Oh, we've got 250. We can go up to 250, 230. The rails here, the rail caps are the rails are going to be plus minus around about 80. So I don't want to choose 160. That's a bit close. Yeah, let's go for this. And you know what? Let's also do the positive side while we're at the same time, because we don't know how these are listed. 200 volts, 230, 250. Yeah, okay. 260 as well I've chosen on that one. Cool. Now let's go for maximum DC collector current. So maximum DC collector current on the original parts was 15 amps, wasn't it? So we want somewhere there or thereabouts. Doesn't have to be exact. So 15 amps, pretty common by the looks of things. 16, 17. I don't want to go as low as 8. That's pretty much halving it. Let's have a look at some of the 25s. Why not? Then let's go up to the positives, 25, 30, minus 17, 16. Let's just get rid of the 30, that's a bit much. 15, there we go. And then we want mounting type. Okay, they're all going to be through hole. Package type, let's have a look at all of the packages. And let's see what we've got. And let's go for price ascending. Okay, so what do we have here then? We have a Toshiba 2SA 1987. Now that is pretty cheap, provided they are actually in stock. No, they're not, because RS Components sucks, and it shows you stuff that's not actually in stock. I don't want 100 parts, so let's forget that. Okay, let's have a look at these. 2SC, these are the NPNs. 5200N. I've seen these used. Are they in stock? Yes. Okay. What is their complementary PNP, I wonder? We'll probably find out looking at the data sheet. So this is an NPN. This is a 230 volts, 15 amp, 150 watts. So all of the specifications are almost identical to our original transistors so far. Let's have a look at the current gain. HFE. 80 to 160. Again, pretty close. We had 55 to whatever it was, 100 and something before. So that's pretty close. That should be good enough. And these are designed for power amplifiers. So yeah, that should be a great drop-in replacement. Base collector emitter, the pinout is the same as well. So what is your PNP? Does the data sheet tell us? No, it doesn't. So if we just Google this and see whether we can get the PNP. Here we go, complementary 2SA 1943. You know what? I might even have some compatible parts available in stock already for this. Let's have a look and see what we got. We have got in stock some 2SA 1941s. Let's have a look. What are those? I don't know these off the top of my head. 2SA 1941. What are you? You are 140 volts, not high enough voltage. Pop those back. What else do we have? We have 1941s again. We have some 2SB, I think that is, 817s. Is that the right code? Yes, I think so. These are 160 volts, a bit close, so not too keen on those either. We need something a bit higher voltage. I'm pretty sure I do have some somewhere. $1943 and 5200. I thought I had some of those, to be fair. Let's dig around in my drawers. Oh, 6011. 1941. C5198. What's that? 2SC 198. Nope, too low. 2SC 6011. That's going to be probably too low as well. Here we go. 2SC 6011. 200 volts, 15 amps, 160 watts. HFE of 50 to 180. Alright, that's looking promising. So, I have those. Don't know if I've got enough. There's not a huge amount in here. What is their complementary? PNP. Ooh, my keyboard is stuck. My C button is stuck down. Too much solder in the workshop. Right, here we go. That's right. Right. PNP. $21.51. Okay, so 1941, nope. 1941, nope. Nope. 1941, nope. 1941 again. I've got absolutely hundreds of 2SA 1941s. Like, genuinely, I could probably sell these on eBay. I've got so many D1047s as well. Like, literally so many. I've got so many of these. Must be absolutely hundreds. Ah, here we go. Right, here's a whole drawer full of 2SC 6011s. So, where is... Here we go, ladies and gents, there we go. Here's the drawer full of the complementaries for those. Excellent, right. So here we go, we have some replacement transistors, fantastic stuff. 2SC 6011A and 2SA 2151A. These, going by the data sheets, look pretty compatible. That'll be the SMD diode you lost 8 months ago, or it said it was in the keyboard. Yeah, jokes. That'd be funny, wouldn't it? Alright, so I need 8 of each. 1, 2, 3, 4, I'm going to make sure they're all the same batch, because I do have a few different batches going on here. 67Y, 64Y. So let's just grab a bunch out, 8 of each. 67's at the bottom. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. There's our 8 NPNs and PNPs. Let's do the same. So we've got 60, we want 67 batch, because that matches the, do I have 67 batch or do I only have 64s? 63, 64. Let's go for 64, why not? 1, 2, 3, 4, 5, 6, 7, 8. Wicked, wicked, wicked. Jungle is massive. Right, so now we've got our replacement parts. We have a little bit more work to do. We have to, I doubt I'm going to have emitter resistors in stock. That would be too lucky. That would. Without the right value. Finally got a live stream. How's it going, Chris? Good to see you here, bud. See you soon is 6, buddy. So we need to suck all of the solder from the holes of this board to make way for our new transistors and new emitter resistors. Now the emitter resistors, like I said, they were reading as 0.2 ohms. So let's have a quick look on the online. So if we want 0.2, let's go for 0, 2, and then multiplier. No, it's 2. So we either want black, red, gold, gold, or, yeah, it's going to be that, isn't it? It's going to be black, red, gold, gold, for sure. Red, black, silver, gold also works, but I don't feel like it would be that. I feel like it would be black, red, gold, gold. So let's take a peek in my resistors tub. This is your favorite, guys. You love this. You love the big tub of resistors, because I don't have a set of drawers with all the resistors in yet, because I don't have enough drawers for that. I have too many parts and not enough drawers. Right, what do we have here? We have 0.1 ohm R10. But we think that it is a bit higher than that. I should probably just look for a data sheet, shouldn't I? Like a schematic or a service manual, that would be pretty useful. We have brown, black, black, gold, gold. That's not going to be right either, because it needs to have red in it for the number 2. We have 0.47 ohm, not going to be that either. Brown, red, black, black, red. It's probably not that. Looking for little bits of red. I'm pretty skeptical that I've got the right value here, but worth a look. R1, so that's 0.1, don't think it's that. Red, 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 gold. Obviously not that. These are 0.47s, yellow, purple, gold, gold, not that either. So, yeah, looks like we are taking to the interwebs and purchasing. Ah, here we go. These are some 0.27s. Now, I wonder whether the ones on this amp are 0.27. I mean, I think I only have one of those, so that doesn't really help. And also, it's a lot smaller in size. It might be the same power rating. We don't really know what power rating these are because they're not marked and they're not a standard package type or anything like that. So I think what we should probably do is just go for like pretty large in terms of package size when we buy some new ones of these. But let's go ahead and search for a schematic or a service manual just to make sure that we get the resistance value exactly correct. Because obviously if I fit new resistors to some of these areas and they're different to the other ones, then there'll be a power imbalance between these outputs, which we don't want. So yeah, no, I don't have any of the right value. That's fine. I didn't think I did, but it was worth a check anyway. So let's just have a peek on the web and see if we can find a data sheet, schematic, service manual, something for this. Now, what the heck is this? This is a Peavy XR 800F Plus by the looks of things. Yeah, XR 800F Plus. So what can we find on the internet for that? XR 800F Plus Peavy. Just make sure we've got the correct part. It's the F Plus that we have. Google knows that. See whether somebody has linked to a service manual. Okay, looks like we might have a service manual for, we've got the user manual here, schematic wanted. All right. Peavy XR, that's not quite the right model. Oh no, hang on, XR 800F. So this isn't the Plus, but I hope that the power amplifier is the same. Let's see. Actually, this is going to be a proper PDF. What the fuck? No! Go away, strange advert that I can't find the cross for. Oh, guys, the challenge. Oh, I got it wrong. The challenge. Yep, no more bikes. Oh man, just found a nice sounding track. Jungle Dem. I'll check that out later. I wish I could check it out on the stream, but yes, it would become demonetized. Alright, this is the same one that we saw before. So, this is full bridge Rex. Okay, outputs are, whoa. I zoom in, but it doesn't zoom in. Yeah, just let me freaking download it, bro. Just give me the actual PDF. Thank you very much. Right. Emitter resistors 0.22, looks like we have there. 0.22. Alright, bloody fantastic. And these parts are 2SA 1302 and 2SC 3281. Are they the same parts that I removed? Probably. Let's have a quick peek in here. 1302. Yeah, this is the same. So yeah, we have 0.22 ohm emitters. Fantastic. We have found out our answer that we needed. So let's go to RS components. Well, let's just remember that we need them. Fuck it. I'll just order them later. So we need 1, 2, 3, 4 emitter resistors. 0.22. Fantastic. Now in terms of fitting these new transistors in place, let's just make sure the legs are long enough. So the heatsink is upside down. The PNPs were on the outer ends from what I remember. So we're going to have to solder them in like this, panda like this, and then just bend the legs. Yeah, that's going to fit absolutely fine because semiconductor technology has come a long way. So previously we needed large package components for this, but we can just use these TO3PN parts and it'll work perfectly fine. Bloody fantastic. Nice and easy. Right. Next thing to check, because we have all the obviously dead output transistors removed, I want to go and check across other places on the board to make sure we don't have shorts elsewhere, because we might have some dead drivers and whatnot. So by the looks of things, this channel here was unaffected up here. This sort of side up here was unaffected. This side here as well looks like it was unaffected as well. So on a good sort of bank here of PNP and NPNs, we should have PNPs 38 on diode mode, 150-ish, and then 38 again. Now obviously this emitter resistor is missing, which means we're not going to get that. 38. Nice. See this. There we go. Nice. Okay, hang on. PNP, NPN. There's going to be this one, this one. Okay. It's not uncommon for you to have a low resistance between these parts here, because that's often how Class AB works. But I'm not really getting consistent readings here. Let's try this side. So obviously we're missing emitter resistor. So this side we've got 37, 38. Should have 150, 150. 38, yep. And then here, based on the other channel, we should have 38, 38. And then this one would be 150, but obviously we've got, yep, 140-ish there. And then this one, missing the emitter, 140-ish there. So let's just confirm over this side. So you're 150. If I go after the emitter, what do we have? Okay, the values are slightly different here. See here we have 151, whereas on this side we have 140. So yeah, slight discrepancies. So I'm going to go ahead and check all of the drive transistors. So by the looks of things, these TO220F package transistors here are likely the drivers, the final drivers. So let's just go and compare what we've got on these. We shouldn't have any dead shorts on any of these. All looking promising so far. Bit of dust. Okay, so that's looking pretty promising. Now, obviously, we do have a 150 ohm actually resistor here that is open, and another one here that looks kind of burnt as well. So that might be what's causing our differences in values. We do have a schematic now, which is great, so we can just confirm the values of those. But yeah, I'm pretty sure these are both 150s. Let's just check a couple of diodes around the area, like Zenas, etc. We could have a failed Zener that caused this entire meltdown. Zenas usually go short when they fail. Let's just check these big ass diodes here as well. Any semiconductor component, it's worth checking for shorts. Takes like a couple of seconds. Little surface mount parts as well. Just kind of generally go over, make sure nothing that obviously shouldn't be a short is shorted. So we might get lucky here in that the failure didn't go back any further than just the outputs and these little resistors here. Cool. Nice. Very good, very nice. Always small transistors dead. Yeah, usually. Although in this one, seem to have got lucky. Tested most of these small boys and they all seem alright. So I think we're going to get away with that. So yeah, just need to fit some new transistors. And then we're good to go. So, bonds on the outside should be the PNPs. Actually, no, are these all PNP? Right, we've got PNP and NPN, I think. Let me just check the schematic for that. So we've got we've got 116, 119, 120, and 114. So let's have a look at what we have for those. So these are our outputs. So we're looking for, yeah, Q116 is the PNP. So PNP is the 116 and 114. And then the QSC is the 119 and 120. Interesting. All right. And just for a sanity check, let's just confirm that the pinout is actually exactly the same, because I don't think I did that for those data sheets. So let's just have a look at the PNP, one of the originals here. Let's just confirm the pinout is the same. So we have BCE, the PNPs here. BCE, fantastic. Same pinout, that's what we like to see. Let's just close some tabs. So yeah, let's get to fitting some of these. Feel free to have a chat with me whilst I'm doing so. Any questions you've got, anything you want to chat about, you're more than welcome to. But in the meantime, it will just be ASMR solder sucking with some different camera angles. I'm at work testing boards while watching, Chris. Chris, what kind of boards are you testing, bro? What's up, Matt? How's it going, my friend? It's me, just my YouTube name changed slightly. What was the reason for the change, just out of interest? It was the name I had on my channel since I was a kid, so I just felt like changing it. No, that's fair enough. The name I had on my channel since I was a kid, Bevids. Can't really change that now, can I? Imagine if I changed my name to like what my company name is, NSV Audio. Everyone would be like, huh? Everyone would just still call me Bevids. Henrik, how's it going, my friend? Good to see you pop up on here. Has anyone used an NVX full bridge line before? Looking at their XAD168K, but don't see many videos on it. Let's have a quick peek on the internet and see what board that's using. I wonder if it is just the NVX XAD16. Do we have any board picks, I wonder? They don't have board picks on the website. Can we tell by the externals what it is? So dual inputs, twin fan. Oh, it's just going to be one of the Chinese Sound Digital clones, going by single RCA input. So I recognize this layout of preamp and the LEDs here. So it's just going to be the same as everything else. I would probably skip that one. I would avoid if you can. Until I see a board pick or some evidence that it is better or different than all the others. Yeah, if it looks like the Sundown SFB, yeah, it's rubbish. Skip that one. Get a Paris or a Terramps instead, it'll be much better. If you were to make your own amps in years to come, what are the top 3 things you'd do differently to every other company? Yeah, I have thought about this a lot, actually. I would love to make my own line of amps, and I have thought about what I would do differently. I've got lots of like crazy ideas that I would like to implement, but probably aren't viable. For example, one idea that I had was releasing just one amplifier. And this amplifier has the ability for the user to set a power figure that they want the amplifier to behave like. So basically just what the amplifier will clip at, basically. So the amplifier will, let's for example say, be capable of 10 kilowatts. Yeah, 10,000 watts at 1 ohm, for example. And because the amplifier has the ability to be a 10K 1 ohm amplifier, the user can set, depending on their build, depending on their power supply, depending on their requirements, whatever the case may be, they can tell the amplifier, hey, don't put out any more than 3K. So you could set 3K 1 ohm, and once the amplifier reached the real limits of what a 3K amplifier would be, it will artificially clip or limit itself and flash the clip LED. You could set like 5k 1 ohm, but because it's a 10k 1 ohm amplifier, you could also set like 6k 2 ohm as your limit, or you could set like 2k 2 ohm, or so you'd have this amplifier that could be everything. And you might think, hey, that sounds great, but that sounds kind of expensive. It'd be better for people just to buy the lower power amplifier, whatever the case may be. I would make this amplifier affordable, so it would end up being a very cheap 10k, but maybe a slightly more premium priced 3k if you were using it as a 3k. But the idea would be that it would be the last amplifier you'd ever really need to buy unless you were doing an extreme SPL build. And it would be tailored towards, you know, bass heads and SPL heads alike. It will be class D, obviously, but super high switching frequency, low THD, you know, low decent specs, so that it appeals to any demographic really. So that's one idea that I had, just to kind of simplify production as well. If I've only got to, you know, design and produce one amplifier, then yeah, hey, that's great. I even thought about potentially having the amplifier run a test. So you power the amplifier up and you like hold down a sequence of buttons, and then it performs a test of your vehicle electrical system to determine what the most amount of power it can safely demand from your vehicle in its current state would be. And that would be really simple. All it would have to do is have a resistor inside on the board. I don't know, maybe like a four low resistance, like, you know, 5 watt resistors in parallel. And then what the amplifier would do is it would then dump current into those resistors and measure the voltage drop on the power terminals whilst doing that versus being idle. And by doing that, it can then determine the impedance, if you like, of your vehicle's charging system to determine, or to be able to predict how much current it can draw from your vehicle's electrical system before, you know, dropping into the 11s, for example, or whatever the case may be. And so then it can come up and say, hey, you know, given whatever this power supply that I'm connected to is, I can provide you with the maximum of 2000 watts at 1 ohm, for example. So that would actually be relatively simple to implement. Some code would probably be required. I would love to do it all with discrete components though. One of the things that I would want my amplifier to be is fully discrete, no MCU, no code, no like proprietary stuff, all discrete and all through hole. I will not be using surface mount components in whatever amplifier I design and build, just because I've seen too many random issues with them. I would want my amplifier to be pretty much bulletproof. I would be very sad if any of the amplifiers I designed failed for any reason, even if it was user error. Another thing that I'd want to have is my amplifier to be like really well protected against user error. I'd want you to be able to short out the speaker terminals. I'd want you to be able to hook it up backwards. I'd want you to be able to drop into the 9 volts. I'd want you to be able to do all these ridiculous things to it and not worry about it failing. So I want to design really robust protection circuits and also over-design and overbuild the amplifier to account for any of those circumstances. I saw a guy on YouTube who repaired a Yamaha B6 Pyramid amplifier. Very cool design. I will look that up later. Thanks very much for that tip, Henrik. I'll go and have a look. Sam, anyone in the chat have any thoughts on solid state with output transformer? So are you referring to like where the amplifier uses, for example, the 12 volts from the vehicle supply to, you know, generate the sine wave based on that, and then have an output transformer that steps it up to a high voltage to drive a speaker? The problem with those designs is the damping factor tends to be stupidly low because the output impedance of that amplifier will be high because you've got a massive transformer in the way. So they don't tend to be very well controlled amplifiers if you've got a transformer between the output devices and the sub. It's fine for things like high voltage, you know, like in shops where you have transformers that step the voltage up and then back down again, so it can travel long distances with minimal voltage drop. It's fine for stuff like that. higher frequencies, you know, not super fussed about the quality, it's fine. But for subwoofer application and people that are demanding nice sound, then it's not ideal. Why is damping factor always so much higher on PA amps? The damping factor is literally just the output. It's literally just the output impedance of the amplifier at a given load. So why is damping factor so much higher on PA amplifiers? Well, things that determine the output impedance of an amplifier is going to be, one of the things is going to be how many paralleled output devices do you have? And PA amplifiers generally will have always classically been class AB, and to get big power from a class AB, you need a bunch of parallel transistors because they weren't able to, you know, throughput huge amounts of current per transistor like they can now. Transistors have come a long way, but classically you need a lot of parallel transistors to get high power output in addition to higher voltages. And when you've got a lot of parallel transistors, the output impedance of the amplifier tends to end up being pretty low because of that. You really like to over-engineer, like when I used a 20 kilowatt inverter heatsink for a 200 watt class AB amp. Yeah, sounds good to me. Maybe a self-diag mode so it can display the issue on a display. That's a good idea, but I don't envision my amplifier having any faults to display. Like, if any of the amps that I would ever design in the future had a fault, like, I'd want it to be so rare that they didn't need the diag mode or anything like that. Like if one of my amps did develop a fault, I would just be like, hey, send it to me, bro. I'll just fix it for you. No worries. Just pay the shipping. I'll just fix it for you. I would want my failure rate to be so low that I could literally just fix them for people for free and have that be like a selling feature. That's how I would want it to go. You know what I mean? I feel like, so my experience in electronics isn't in electronics design, but it's fixing stuff that's broken. So I have so much experience seeing what breaks and what causes stuff to break, right? So I feel like, yeah, maybe I wouldn't be able to design the most nicest sounding amplifier or whatever, the most optimized, perfect, balanced, whatever bullshit, thing, because I haven't gone to college and done circuit design, amplifier design. But I would hope that given my experience, I would be able to design an amplifier that's near bulletproof, because all of my experience is in seeing what has caused problems and fixing them. So I would hope that that would then allow me to build an amplifier that was extremely reliable. So start popping some of these transistors in. Obviously we don't have emitter resistors, so we're not going to be powering this up this evening or anything like that, but I would like to have the outputs fitted at least ready then for now obviously they don't screw in this way. I'm just putting the screw in there to make sure that it's lined up with the hole, so that we're then ready for some emitter resistors when they arrive in the post, and then we can power it up. Now when it comes to powering this up, gents, obviously this is a mains amp, so I don't work on mains amps typically, so I don't have a Variac or any fancy sort of mains special safe power supply thingy, whatever. So when it comes to plugging this in, I will literally just be going full YOLO into the mains and seeing what happens. But before that, because fortunately this is an older amplifier and it's very simple in its power supply, I will literally just be fully capable of injecting my own auxiliary supply rails to this, plus minus 15 volts, and also my own rail voltage at whatever rail voltage potential I would like, and the amplifier should then come up and running and produce audio. So that's what I'll be doing first before I plug it into the mains, is injecting my own supply and rail voltages just to make sure that nothing gets hot or there's no shorts anywhere that develop, etc. And then once I'm happy with that, then it can go in the mains. So yeah, this is a powered mixer. So this is the amplifier side. So those are the rail caps. Some random said, with no engineering degree, I managed a Class AB amp that has no hum or white noise. I forget the thing's even on. That's really nice. Good job, bro. That is an achievement. Good job. You'll need a programmed microcontroller for the health check. I disagree. I think I could do it discreetly. Like, genuinely think I could do it discreetly. Not necessarily like, when I say discreetly, I don't mean like individual transistors and stuff. Yeah, I might use some ICs in there, you know, some chips, but they won't be like programmed with firmware. I want to build the amplifier so that it is fully repairable by anyone, anywhere, if it did fail. Not that it should, like I said, I'm not planning for the amp to fail ever, but you never know, things happen. I would also gladly release full schematics, datasheets, and repair guides for people if it ever did fail. So another idea I had, so obviously I've spoken about the idea I had to have an amplifier that is all power ratings that you can then select from. Another idea I had would be to design like the main amplifier sort of circuit, I guess, like the drive circuitry, etc. I designed the drive circuitry and the preamp circuit and everything like that around a 10K amplifier. But then I would it maybe be in the same size heatsink or whatever. But then I would sell different power ratings of that amplifier with like less or more MOSFETs and rail caps and different transformers and stuff. But where they would be hot swappable, so not hot swappable, but where they'd be interchangeable, so that if somebody bought the 3K version and they wanted to go and have 8K, they could they could buy the 8K parts, and they would just literally bolt out the transformers, power supply FET modules, output FET modules, and maybe output inductor modules, and just bolt in the 8K ones, and maybe a little daughter board for changing the protection circuitry and stuff like that, and that would then just work. I don't know how realistic that is, or whether that's even like possible, but that's just another idea that I thought, maybe I could explore that kind of vibe. Okay, just a heads up, guys, I might just have to nip to the front door in a minute, because I might have somebody coming to pick up some amps. I like the all-through-hole idea as well. For some reason, I like working on those more. Yours would have no issues to fix, as you said, though. Yeah, hopefully they would have no issues to fix. Yeah, I just tend to see amps that are all-through-hole just tend to be more reliable. And there's less and less of those really nowadays. Right, Q101. What are you? Q115, Q101. Q101, you are the PNP, as I thought. And then 102, also probably PNP. Yep, 2SA. So the PNPs are on the outskirts and the NPNs are on the insides. That's just how we roll. All right, yes, my client is outside, so just bear with me for a second, guys, while I give him the Hyphonics amps that I fixed for him. One sec. All sorted, there we go. Happy customer. Green socks. Oh yeah, I do have green socks. Well spotted. Yeah, so yeah, I've seen a few boards like that as well, where it's yeah, one sort of base circuit, one circuit layout that then has more or less components depending on what kind of model they're going for. It's a cost-effective way of designing and doing it. I would just go one step further and give the end user the ability to kind of, you know, upgrade and swap out some of those parts. But yeah, I don't know how viable it would be. Yo, Sam Perry, how's it going? What have you missed? Just looking over this Class AB powered mixer from Peavy. Whole bunch of dead outputs, PNP side, dead emitter resistors. So we're just loading her up with a whole bunch of new parts right now. Sadly, we won't be able to probably power this up this evening because we don't have the right value emitter resistors in stock. I shall order some and we shall continue. I also need a couple of 150 ohm surface mount resistors, which I do have some 150s, but I don't know if I've got any that are the right power rating. I think they're a bit smaller than the ones that this uses. How do you manage bending the legs at just the right amount on every amp you've ever repaired? What do you mean? Just kind of put it in till it's in the right place, and the legs just kind of bend themselves a little bit. The legs just kind of bend themselves into the right place, I guess. So we should have the same order of things on the other channel. So PNPs should be over this side. Although interestingly, they're not. It kind of seems like, yeah, we do. We have separate rectifiers. So yeah, each channel has its own freaking power supply. It's kind of a dual mono, even though it's coming from the same transformer. It looks like the transformer has separate secondaries, separate secondaries, and separate full bridge rectifiers for each channel. That is pretty wild. Oh wait, no, they are actually the same. Bro, I'm not gonna lie, this is kind of baffling. No. That doesn't make any fucking freaking sense. That one should be connected. Yep. And that shouldn't be connected. What, 39? That's just going to be the rail, so we got a short on the rail somewhere. Doesn't make any sense. What? Oh, I see what's happening. I'm getting a short through the screws that I've got fitted through the case. I was like, hang on a minute, why is there 30 ohms between the two rails? That doesn't make any sense. And we still have. What's going on? Ah, wait, of course, the legs are not chopped. So yes, it is still going through the case. No worries, that's fine. Ba-da-ba-ba-da-ba. Right. Let's get these ones fitted over this side. Long time no see. Hope's life been treating you well. Yes, it has, my friend. Life has been absolutely great. Loving life. All good, my friend. Hope you're well as well. RTS. See my comment about the emitter resistor. I didn't see it. I don't see it still. How long until the multimeter battery runs out? I don't know. Usually it stays on like low battery for ages, and it's fine. Unfortunately, this battery did have a decent amount of life left in it, but I left the multimeter on overnight one time. So now it's kind of drained, sadly, because it's a cheap multimeter and it doesn't have auto off. So yeah, just cooking my way through 9-volt batteries for the fun of it. Do you know how much sound quality you lose over Bluetooth compression? It does depend a lot on the piece of kit, the Bluetooth receiver. Depends on the DAC quality in the receiver itself. Depends what type of Bluetooth it is using, because there are a few different protocols that have different amounts of compression and stuff. However, what I will say is if you're thinking of buying a turntable for its turntableness and then have it be Bluetooth, that kind of defeats the point. That sounds like a waste of. That sounds like just using Spotify or like Alexa or whatever, but with more steps. Or just connecting your phone, but with more steps. Like, it kind of defeats the point of having a turntable, in my opinion. So Latvian, your auto off sounds like it's just on a basic timer rather than on like a values changing thing, which is really annoying. That would drive me nuts. I would hate it if my multimeter's auto off was just on a basic timer. That would suck. Chris said, oh, that reminds me of my first amp I worked on. I forgot to cut the legs. Ah, we've all been there, man. We've all been there. Mistakes like that. It's cool. It's how you learn stuff. I did a similar thing on a nice Audison. Can't remember what it was. Some Audison AP something. Used the TDA output ICs, the fully integrated amplifier ICs. And obviously the cases, the tops of those are what you clamp to the heatsink. And I hadn't realized that the insulating pad had like fallen off from the case. So I screwed it all back together and powered it up, and all of the TDA chips just shatter brick. And they're very expensive. They're like £20 each or something like that. So I was like, ah. Okay, fantastic stuff. So let's get all of these soldered in on this channel. And then, once that's done, we are just awaiting emitter resistors and 150 ohm surface mounts. Gents, I bought some new solder the other day. So this is your regular roll of solder. Okay, you love to see it. Regular roll of solder. Now, gents, check out the Chongus. Regular roll of solder. The Chongus. Bro, it's freaking massive. What the heck? Why is everything I buy oversized? Compensating for something there, buddy. Oh, dude. If I was having to compensate, I'd need about 10 of those. Just to compensate. Bro's packing the modern efficient Class D micro size semiconductor package, bro. Right, transistors all fitted. Nice. Love to see it. So they should be good to go. We do need, like I say, we do need some emitter resistors. So we shall order those. What I will do though is I'll do some new thermal paste just now, and I'll put the heat sinks back on these ones. Now, one thing I've just realised, which might actually come back to haunt us a little bit, is this a Class AB amplifier. This doesn't have adjustable bias. Now when fitting, especially when fitting compatible alternative output transistors, they will often need a different bias point compared to the originals. So we either just, well, obviously when we come to power it up for the first time, we'll have to see whether the idle current draw is excessive and the outputs heat up quite a lot, in which case bias is too high. Alternatively, if the bias is too low, then it will draw barely any current, but will get crossover distortion on the scope at high frequencies. When did you start to work on amps? Did you receive training? So I'm completely self-taught. I've never once done any electronics classes or training or anything like that. I had a bunch of dead amps that I was distributing to the UK for a while, and it was either a case of cut a loss on them or send them back to Brazil to be fixed, or just learn to fix them. So I just learned to fix them and enjoyed it. And Perry's Guide. I guess Perry's Guide you could call the only bit of like training. So really good bit of info, Perry's Guide. So yes, I asked some assistance from some other people I knew that repaired amps, similar to how you guys might ask me a question. Oh, what should I change in this instance? Whatever. And had Perry's Guide, obviously, which was massively helpful. But apart from that, yeah, nothing. Can you squeeze in some pots? So I typically don't repair Class AB enough to know where I would have to put potentiometers in for adjustable bias. I'm not really a Class AB expert. I can repair them. I can find faults in Class ABs, but modifying one to add adjustable bias, I wouldn't really have a clue what I was doing in that regard. I couldn't even tell you where the resistors are that set the bias point. You know, that's how little I know about Class AB compared to Class D. If this was Class D, oh yeah, man, we'd be adjusting the freaking dead time, be adjusting the switching frequency. I'd know how to do that, all things like that. But no, with this Class AB, not so much my area of expertise. Ah. Fortunately though, if I did need to add or modify the bias on this, I do have a schematic. So probably by looking at the schematic and maybe doing some reading online, or even asking some friends that are more expert in Class AB than me, we should be able to figure out a mod that would change the bias point if needed. Sick. Right, that's ready for some emitters and some surface mounts. Now, these heat sinks don't appear to have any, they don't have any insulation. So on the back of these transistors, I assume is just the output sine wave. So these heat sinks are live at all times while the amplifier is up and running. Cool. They don't touch each other. Yeah, that should be fine, I guess. If it's just the output sine wave, it's all common, isn't it? They're probably all common anyway, aren't they? It's not just the output. Yeah, they're all common anyway. So that's fine. Good stuff. Good stuff. Bisam, hello. Yes, all is well, thank you. Very, very good. Okay, cool. Right. If I can fit this somewhere on the floor, because the workshop is just absolutely exploding at the moment with far too much stuff going on. Let's pop this down. Just behind me here. I think I've got a bit of space. There we go. Right. Now, let's grab something else to work on. In the middle of replacing every blooming MOSFET in one of these Zen and Fullbridge 10Ks. So while we're here, let's just continue with that, shall we? Does anybody recognise this board layout? Do you recognise this? Heaps of trouble, heaps of problems, oftentimes, but is what it is. Get there. Right, this one needs a couple more gate resistors. And then some power supply FETs. I think the drivers are okay because I fitted 667s in this quite a while ago. So that should be fine. Gate resistors. Now these I think are 22s. Yes, it's a vibe or an edge. Edge. It's an edge. What? Oh no, 10? 10 ohms. These are 10s. Alright. And a lot of them are actually open even though they look visibly okay. 10.6. Damn, okay, fair play. A lot more of these are dead than I thought. No worries. I think we'll just replace all of them. Alright, we're going to replace all the gates first. No worries. Is that really fine? Usually these gate resistors, yeah, when they go open, they like visibly burn. They're one of the few that made use of threaded inserts on the terminal. Yes, you're right. They are one of the few brands that made use of threaded inserts. Oh, yeah, it's open. Weird. Strange resistor failure. No worries. Both my favourite channels are live. What are your favourite channels, Henrik? Who else is live that I have to compete with for your attention? computer building channel on TikTok. I actually tried going live on TikTok one time. Yeah, it was pretty interesting. I think the problem is with my live content, it's a little bit too slow paced for TikTok, I think. I feel like if I was going to do lives on TikTok, it would have to be a little bit faster paced. Maybe like a amp repair speed run or something like that. The attention span on TikTok is markedly lower than on YouTube, I think. Alright, sweet. Now, what gates should we put in here? Probably some 10s, put some 22s, but I think probably some 10s. How about doing videos on people's systems? I don't think that would really get a lot of views, to be honest. It'd be cool for the person whose system it was, but for everyone else, I'm not sure that would be super interesting. Is that a new hat cam? Not super new. A few years old, I think. A couple of years old, maybe. 60 FPS. It was a very, very, very kind gift from a viewer. Someone saw me struggling with my hat cam shenanigans and decided to purchase this Logitech Stream Cam for me to use, which was mega kind. So yes, freaking awesome. I'm just picking out all my 10 ohms I need. I remember when it was like 15 frames per second streams. Yeah, back when I started streaming, everything was like super low frame rate. I was using old Logitech webcams from like the early 2000s, and yes, quality was not the strong point. Now, Smart 3K I sold a while back, just went up in smoke. Terrance is making it right with the owner. That is one of the reasons why I recommend Terrance a lot these days. I genuinely believe they make a good product anyway, but they are, honestly, out of all of the different car audio brands that I've come across, one of the only brands that genuinely, like, really helps out their customers. Like, even if the amp's a little bit out of warranty, sometimes I still find that they'll, just send them a new amp, like, or sort out the repair or something. And they don't immediately jump to conclusions that it's user error, like so many brands do. And they won't pay for warranty, or they won't do a repair under warranty or anything like that. Yeah, they just seem like really nice guys, really customer focused, and that's worth a lot in my opinion. Alright, next side. All the gates on one side done. Let's flip it over, do the others. I really hope that the drivers are okay. In these amps I fit 676s, which are actually a bit expensive, and I haven't bought 676s this time round. But I bought 676s last time I bought PNP power supply drivers, because they don't fail when the power supply goes down. They just survive every time. Yeah, I definitely recommend getting a Smart 8, even if you don't need that much power. Just having the dynamic headroom is super nice. It will mean that your kick drums are really, really like strong, transient. You're always going to be miles away from clip point. It's a good idea to have more power than you need on tap, just for the headroom. I think Terrance are close to releasing a Smart 12, which should be pretty exciting. I'm really keen to see what that looks like. The big bass 8 is another I'm thinking about. So it's the same amp. The Big Boss 8 is the same as the Smart 8, provided you buy a current model. The only difference is the lights. If you check out my review video of the Big Boss 8, you can see that on the PCB it's marked Smart 8 base and Big Boss 8 base on the same PCB. So it's the same, provided you buy like a current revision one. What's your opinion on Hertz amps? Hit and miss. I'm not a massive fan personally. From what I've seen, it doesn't really look like they really do their own designs. They're very, very expensive versions of circuits you could otherwise get from other brands, from what I have seen, for the most part. So not the biggest fan of Hertz amplifiers, but they're okay. They're better than a lot of other stuff you could go for, but they do seem a bit overpriced for what they are. Okay, time to put some power to the board and just check that all the drive waves look okay. Right, turn the scope on for the first time this evening. Right, so yeah, looking for good, sharp PWM on both banks. .6 on that one. Yep. 5.5, 6, 6, 5, 5. 5.2. That's a bit too low on this side. I know it's only like a little bit, but it is a bit too low. Also, I don't know if you just noticed the idle current changed wildly there. It was like 0.6 amps, now it's 0.3, so something's changed. So I think we have a failed driver on this bank that is 5.2. Yep. Yeah, that's too low. So that's going to be one of these to here, most likely. .2. This is 5.2 as well, actually. That's interesting. It's a touch lower on both of these sides, which are different transistors, which suggests that actually it's not the 4.0, 4.0, and then 4.0. Interesting. We'll have to see how that behaves with some MOSFETs fitted, but I'm not super keen on that. But all the drive waves are present, just not exactly the same voltages, which is a bit worrying. So we can see how it looks when we get some FETs in, I think. Let's just check the drivers. No, okay, yep. We do have a very dead driver. It looks dead. It looks toasted. Right, let's just remove that. So that is the 6. I thought the 676s were supposed to survive anything. That's what I was told and what I experienced so far. Will you make any more videos like the bass demos? I don't know, it's not really my thing anymore, like, to be honest, bro. Yeah, I don't really know if I'll be doing any more like bass demo videos. I don't know, we'll see. I don't really have like a loud build in the Proton, and the van is the van, which you've seen already. I don't know, maybe, we'll see. I don't super love the van build though, that's the problem. I'm not super in love with the van build. Ah, 667. So the box in the van isn't right for the subs because the box was designed for much lower powered subs. I also don't like the subs because the spiders are awful, they're rubbish. Magnets are amazing, cones are amazing, coils are great, spiders awful and just ruin it. But yeah, the box isn't really designed. The van, I reach mechanical excursion limit before I reach anywhere near the sub's power limit, and that's just really frustrating. That's just because the box is obviously built for smaller, like not smaller size, but lower powered subs. It's pretty easy to change spiders. No, it's not. If you try changing a spider on a Digital Designs USA built sub, it's not easy in the slightest. It's like a full recone job. There's no way you're getting the spiders out without damaging everything else. Okay, so that is, I think I was on the wrong camera for all of that, sorry for that. So that is now new PNP driver, so hopefully we should have equal drive now. Across these, let's have a look. .55. That's better. 5.55. Yeah, that's better. I know it's 5.6 on these ones, but tolerances. Yeah, so it's easy enough to replace spiders on like lower powered, softer spider subs that use sensible glues. Digital Designs glue, I'm not even joking you can't soften it up. It is brittle. To remove the glue joints, you have to like snap everything. You have to destroy the subs. Anyone who's dismantled or reconed a Digital Designs USA line sub in the past will understand the glue that they use is very different to what you're used to seeing. You can't do it. If you could do it easily, then yeah, for sure I'd do it. But no, it's a recone. Cool, so this is ready for some power supply effects. Now I've got a whole bunch of them back here. What I would be tempted to do with the subs is to keep the motors and build some hybrids with the DD-Z4 motors, maybe like some FI audio soft parts or something like that. I'd be tempted to do that, but then it's just a waste of the good DD soft parts that are really expensive and the really expensive powder coating on the baskets and everything like that. Like, they're beautiful subs. It's just such a shame they're let down by the freaking spiders. And DD have changed what spiders they use now. They use iron cloth spiders now, which I assume is as a result of the issues or whatever that the other ones had. But it's just a shame that I'm now stuck with it. Do a build with the Carnage. Carnage, yeah, they have the 12s. I am not going to be doing a build, if that makes sense. Like, I don't really have the energy or patience or desire to like do a fresh build. I'm not a fabricator. I don't like the woodwork stuff. I don't like all of that nonsense. So if I was going to do something, it would be just putting new subs in what I already have, which is the van. So if they made some Carnage 15s, then I'll put some Carnage 15s, perhaps, just for fun. But again, because the box in the van, the 6th order, is designed for lower powered subs, the scores wouldn't be that impressive with the two high power 15s, because the box is essentially too big and the port area is way too small. There's nowhere near enough port area. So it would need a great deal of box modifications to actually, you know, be competitive or be impressive with big subs. And yeah, I just literally don't have the energy or time or patience to do the box mods myself. And I don't have the money to pay somebody to do it either, so... I don't know what the box sizes are off the top of my head. I just know that it's not right for the DD-Z4s. No, I don't want to use base face team reds. I mean, I'll give them a go, but like I say, I'm not super invested in the van. The chances of me changing the subs, and bear in mind the DD 15-inch ESP subs have a much bigger basket than most subs, so if I was going to use some other 15s, I'd have to make adapter rings, and that's just something else for me to do that's going to make me be like, nah. Do you know what I mean? I'm already like, nah. So if I've got to do anything extra effort, then it'll be like, nah. The van's going to be for sale. I'm going to sell the van As soon as I've done the audio pipe mod part 3 video with the van, because I obviously want to use the van to showcase how loud the little audio pipe is. As soon as I've done that video, then it'll be out for sale. I think I'm going to use the big soldering iron for this. Let's get that heated up. How's the Big Boss 3K? Yeah, pretty good. Very, very similar to the Smart 3. Not much changes there, really. I don't like one thing about it. There's a couple of things I don't like about it. I don't like how it's hard to explain in a simple way. Basically, there's a design limitation that they've hit using the IRS 2092 drive chips with a single rail voltage amplifier. And it means that the duty cycle of the output Class D switch wave varies depending on the rail voltage level. And the rail voltage level varies with the battery input voltage. So basically, the amplifier is always going to be sandbagged. It's always going to produce less power than it could or should, either at 14 volts or 12 volts, depending on where the circuit is optimized for. And that is kind of a shame and annoying. It will cause the sine wave to clip early at the top or bottom of the sine wave, depending on how it's been optimized. And I initially assumed that was a design feature that they had done to prevent the amplifier from trying to produce too much power. I first of all noticed it on the HD 3000, so I was like, okay, interesting way of limiting the amount of total power at 14 volts, but fair enough. But have now come to realize that it's not. It's a design limitation from using the 2092s. If they'd used 20957s, like the other Smart 5, Smart 8, etc. do, then that wouldn't be the case. But that doesn't mean it's not a great amplifier. It's just something that slightly annoyed me, and I was like, oh man, that's a bit janky. But it doesn't mean the amplifier is unreliable or anything like that. You can see from the dyno videos, it produces ridiculous amounts of power. It is a pretty solid, well-designed amplifier, and it's incredible value for money. So yeah, there's nothing wrong with it, and I would still recommend you buy it if you're in the market for something around that power. But yeah, just compared to like the Smart 5 and stuff, it's not quite as well optimized in terms of circuit design, architecture and stuff like that, in my opinion. Right, that's one side effects fitted. It's 10 PM here in the UK, so I actually think I might leave it there. Go and chill out a little bit this evening before I go to bed. But guys, thanks for hanging with me for this evening. It's interesting to look at the Peavy together. It's just nice to have a chill and chat, and I massively appreciate anyone who shot some coins over to me for the inevitable PC upgrade in here to prevent it from crashing. Although I have been streaming now for 2 hours 5 minutes and it hasn't crashed, so it seems a bit random, intermittent. It doesn't crash every time, just sometimes. Yeah, hope you enjoy your rest of your evening, guys, wherever you are, and I'll catch you in the next stream. See you later.